Hi, this is John with Fix It Planet. Been away for a little while, lots of work going on. We have the HAC-001 with a physically damaged USB-C port where the device is charged and connected to the dock. So needless to say, this one is physically damaged. You can see down inside there, so it's pretty obvious that one's going to have to be replaced, although there are some other reasons why the unit may not charge. We're going to have a second video coming up after this one that touches and goes over the process of replacing another integrated chip. So this one is just going to be about the charge dock assembly, or the charging port that you will need to replace on here if you want to be able to charge it again, and also if you want to be able to get external video using the dock. You will have to pay close attention that you do this process correctly. And so we do have 4 Y or tri-wing screws in each corner on the back here. So those are going to be the first screws that we remove. You can use a 00 or a single 0. I think either one seemed to get the job done. Looks like I had a 00 on here. I've got another 0 in my hand now that seems to work okay as well. Make sure there's no games or anything in there. There's your volume and your power buttons. So we're going to have a couple of screws here near the port. They're just regular Phillips. This very small 0 Phillips O, PO, P0. They don't really respond to anything magnetic, so they just kind of drop out. Be careful that you don't lose them. We're also going to have a one here on either side as well. So you had the one small one on the top of the unit, and 2 on the bottom near the charge port, and these 2 on the sides. They can all be removed using just a standard Phillips drive. Screwdriver. There was one other tiny Phillips screw underneath the kickstand as well, we took out earlier in the beginning. You're going to have a bunch of more sort of silvery Phillips screws that are going to take this shield off, or hold the shield on. And we're going to take out this this card slot with this screw here and a little pop connector. Again, just another Phillips. So if this is broken for some reason or messed up, it's very nice and convenient. You can just buy another one and pop it in there. So I'm going to go around and remove all these screws. I'm just going to point at all the different locations where these screws are. Looks like I forgot one. There's going to be some thermal paste on the other side here, this sort of orangey, pinkish looking stuff. Don't know what color that is. Looks a little bit like silly putty to me, but either way, we're going to leave that alone. We're going to disconnect the battery first thing. Just taking a shot of the battery there so you can see exactly what the model is. There is actually a different battery for the light version of the switch. They do not have exactly the same battery. We've got a couple of speakers here we're going to disconnect, and we're just going to go around, disconnect all the cables, and we'll pull all the screws out and so on. These are, again, all Phillips screws. You're going to have mostly silver screws, but then the ones that hold the motherboard in itself, the main logic board, they're all black. So just kind of keep an eye on where all these screws are located, where they're coming from. Make sure that you map it out some way or another so that you can remember where to put them all back. Obviously, you can always refer to the video if you need to. You can see these little latches that just hold down those flexible cables. They can actually break. You will have to take this heat sink out before you can fully get the fan out of there. There's a couple of screws underneath the actual heat sink pipe. I think towards the end of the video, when I'm putting all this back together, I actually forget about one of those screws, I think. Not a fan screw, but another one that holds the logic board in. Ended up putting all of that stuff in there and had to take it back out to get that screw in. So just try and remember, because I seem to have difficulty with that. So again, you can see there's some thermal paste here. You can reuse the thermal paste if you prefer, or don't have any to replace it with. We're going to go ahead and clean this off and put some fresh thermal paste. If you do want to reuse the old thermal paste, just try not to lose it all by wiping it off or anything. You can collect it up a little bit like that, and then you can sort of reapply it if you want to. I don't really recommend that. I recommend replacing it with some fresh thermal paste. So I'm using my new computer to do the video editing with. I'm really thrilled about the new tools. However, I had to change the video editing software that I was using prior to this new computer coming in. So initially I was having some difficulty with the software, glitchy, thought maybe this computer just basically sucked and wasn't working. So I spent, something like $3,000 on this really expensive machine, and then I got it back and installed the software, and it still sucked. So it was kind of like, okay, so yeah, that didn't work out so well. But it was okay because it pushed me into, doing something, using something else. And I've used a lot of different software over the last couple of decades, or more. It's just that, you know, you get into a comfort zone, you don't want to have to learn something new. I'm always having to learn something new, so I kind of try to eliminate anything outside of the what is mandatory, what is necessary, what is required. So if I can get away with it, I'll just continue to use whatever it is I'm using in the meantime till I decide that that no longer works for me. So some of these videos, all of these things should actually start to come together much better in the future. I'm going to have more flexibility. You know, sure, if I want to use a green screen and a 2 or 3 camera setup, I could do that as well. Not a real big fan of all that extra stuff. I just kind of like to focus on the repairs. But audio is a big deal. Obviously, the quality of the image is a big deal. The instruction is also useful. So audio right now is not quite ideal for me. There's a lot of background noise that's not being isolated out. So these things hopefully will improve over time. I've actually got a full, complete audio and video recording and production studio that is equipment-wise is all here and available to me, but it isn't assembled. It's not put together really in a coherent way. It's a lot of digital audio gear and some other gear that I could set up if I wanted to, but it's a lot of work for me, and I don't really have time for that right now. These videos are all fairly rudimentary in scope. They just basically want you to be able to see the images very, very clearly and hopefully get the point across. So we now have the main logic board out. Hopefully you will enjoy these videos, at least anyway, and find them useful. And if you do, certainly by all means, please like, share, and subscribe. It really helps us out when you do that. So you can see these three, this first set of pins. There's another row behind them, underneath, that you cannot see here. This is what tends to throw a lot of people off, as they have no idea how am I supposed to solder those to the board if I can't see them or touch them with my soldering iron. And that's because this is not done that way. This is done as if you were putting something like a surface mounted integrated chip or resistor or capacitor, something that's going to be SMD or surface mount. So we're going to switch now to the microscope view. We're going to put a little Kapton tape just kind of as a precaution. Basically just want to make sure that we don't accidentally get something loosened up with the hot air and then knock it off or something. So we use that to help protect against some of that. The process again for doing this is going to be very specific to this type of connector, which is done just like any other SMD component, which means that instead of trying to solder the interior pins, or even the outside pins really for that matter, with a soldering iron, we'll be using a hot air station. And in this case, the hot air station will be set. We'll be using the Quick 861 DW with the airflow at about 120 and the hot air, I believe, is 800 or 750. Can't remember now. Somewhere in that ballpark. And part of the reason for this is because we want to heat this up very quickly and get it over with very quickly. We do not want to keep the heat on this port for any longer than is necessary, because we also have plastics that we have to deal with. nylon, plastics, whatever composite they're using inside the port itself as well. So first what we're going to do is we're going to heat this thing up and get it taken off of here. We want to be extremely careful when we're doing this that we don't rip any pads off of the board or anything that could prevent us or complicate the repair for sure. You can see this is the secondary row that's back in the back behind the row in the front there. This is where the second row of pins is soldered and attached. So there's a whole lot of data lines on here that allow data and video, imaging, graphics, these kinds of things to transfer through the charging dock and go out to an external monitor and things like that. So if you don't do this row back here, you're not going to get that video, audio, video, any of that stuff. Gonna have a problem. So some people I've heard are just soldering the front row and basically getting it so it will charge again. But for whatever reason, they're not able to get the rest of the port on properly, so the back row there is not being soldered on. Granted, you can't really see when they're being soldered if the pins are soldered or not, so you kind of have to practice a little bit, get a pretty good idea of what your solder looks like when it's melted, what your thresholds are, what's too long to keep the heat on, for example, before the plastic melts. All these kind of things you might want to run through the practice once or twice at least before you try to go for the really good one. So for a proper repair, all of those pins and both rows of those pins have to be 100% soldered on there. So ideally, if we can see the solder melting on the outside pins that we can see, then it is very possible and very likely that the ones inside behind it are also melting. So that's a good indicator. But one of the things we're going to want to do before we even get started is we're going to want to add solder to all the pins in advance. So you might call that tinning. So it is tinning effectively. But we're also adding basically a reasonable amount of solder on each pin so that we don't have to add solder to them after the fact. In other words, we want to make sure there's more than enough solder or adequate enough solder on each one of these pins in order for them to be properly soldered. This would be a lot like if you had an IC that had a ball grid on it. So if it had previously had balls of solder underneath it, then that would be something similar to what we're doing here. We're just making sure that all of these pins and all of the pads as well have a adequate and sufficient amount of solder on each one of those pins and each one of the pads that correspond to those pins prior to the attempted approach of soldering it on. This is going to help to ensure that once we heat up the solder and melt it, that everything will settle down inside underneath and everything will be hunky-dory, happy again. We've also got to remove all the old solder out of here. So the original solder was probably not a leaded solder, which means that it is it melts at a much higher temperature. It makes it a little more difficult to remove. So you can add, if you prefer, you can add a low melt alloy or something to that to sort of aid and assist you in removing it. And then we're going to be using just a leaded solder to put it all back. Once we've removed all of the solder out of all these little holes and pins and things, we're going to clean it up, and then we're going to tin those pads with a sufficient amount of solder so that we can get that new port on there. We're using a little bit of this low melt alloy to kind of assist in getting some of this out of these thicker holes. Sometimes I can get it out without the metal alloy, and other times, for whatever reason, I can't. So my soldering tips might vary a little bit, but if I happen to have this particular soldering tip on there, I may not want to take the time to swap it out with something else. I'll just work with whatever I have. So all that looks pretty good, except that later we're going to start adding solder to those pins, and I'm going to accidentally fill up one of those holes again, and we'll have to do that one over. All we've done here is flip it over to the other side. We're just inspecting it and kind of looking to see if there's anything there that we might need to remove with the wick. In case you don't know, we're using a little flux and some solder wick wire that's all sort of run together that soaks up the solder and removes it from the surfaces. Okay, so and that's also fine the way it is. I mean, if there's just a teeny tiny bit of solder in there, it's not the end of the world. I can easily put the port in there as long as I can get the anchors down into the little holes that they go into. I can just heat it up and it will be fine. I don't literally have to remove every tiny little amount of it, but it is something that I would attempt to do if I could manage to get it all out. That would be kind of cool. I'd like to get it out of the way so I can just drop it down in there. But if I can't, and I just have one side that still has a little bit too much or something, and it's preventing it from laying flush on the board, and I just heat that side up and then settle it down in there. These all look pretty good though. If they'd stayed this way, it would have been great. But as we'll see here in a moment, it doesn't. So what we're going to do now is we're going to add solder to these pads. Where each one of the pins are going to go. It's just a slight mound. Yeah, we just filled our holes up there. We will have to clean that up again. But we're just making little mounds on each pad. Now I got to come in and pull all this out. Okay, we're back to where we want to be now. Cleared that opening. So basically at this point, I believe we're good to go. Let's see. maybe adding a little more. Oh, that's because when we cleaned it up, I wanted to touch up the areas there just to make sure we had enough solder on each one of those pads. That looks better. Looking good. Now we just need to clean things up. Okay, so now we're going to basically make sure that all the pins are truly lined up with each pad that they're supposed to correspond with. So we want to make sure it's lined up as close to perfect as we can get it. And we're going to apply some pressure, some downward pressure as we get started. The first thing we're going to do though is we're going to anchor, we're basically going to apply a little bit of solder to some of the anchors to sort of hold it still so it can't move on us. I can barely get that tip in between there. A little bit smaller tip would have been a little better. But we get it done anyway. If the tip had been any bigger, it wouldn't have fit at all. So we're going to make sure that each one of these anchors has got basically a sufficient amount of solder on each one before we get ready to flow everything into place using the hot air. Once the anchors are in place, then we're going to put a little bit of downward pressure on the port, and we're going to use our hot air to flow everything into place. Now you'll be able to see the solder start to melt where the anchors are and also on each one of the pins. So as that occurs, then you can pretty well use that as a sort of guide or an indication that the solder joints are all melting on the inside as well, the areas you cannot see. Then we'll come back and check with just a X-Acto knife blade to make sure that those outside ones have all been nicely soldered into place and are solid and not moving around. If they have, then most likely everything is soldered into place and we should be good. Now granted, if for some reason this process fails and you don't get it to solder on the inside, you only get, maybe one more chance at reflowing it and before you're going to take it off and start over. Do it again. So we're just going to take a look at it from a different angle. Check it again with these. So any that I find that are loose, if there are any that are loose, then I'm going to assume that the ones on the inside that I cannot see did not get fully soldered in place. So then I will bring the hot air back in and run through that process one more time before I start to decide maybe whether or not I need to take it off and start over. Basically, as long as the solder has a sufficient amount on each one of the pads, you should be good. We just don't want to melt the plastics of the port, so we don't want to keep the heat on it any longer than we have to. Looks like I needed to touch up this one leg. Okay, so we just pulled all the Kapton tape off. We're going to scrub this up and clean it really well. And then we are going to put it back into the actual housing and everything and give it a test. Again, if I just wanted to remind everybody that it has been a couple of months or so, I think, since I was at last able to do any uploads. However, I do have at least this video and another one a little more in depth that are ready to go or almost ready to go. This one I'm just finishing up, obviously. The other one is yet to be put together and assembled, but all of the shots are there. And so we'll be uploading that again probably around the first of next month or the middle of next month. It is possible, it is conceivable that I may have it up before the end of this month, but it's not anything I can know for sure. Scheduling uploads has not gone very well for me. There's too many things going on at once that I have difficulty in really scheduling much of anything at this point, other than just showing up and doing what I need to do. So I've been really busy, and most of the time I'm by myself, so I don't get a whole lot of help. At least not in terms of the repairs anyway. I'm pretty much on my own with those. And it's they're coming in faster than I can get them done at this point. So it's making it really difficult to have the time to go and do any of these videos. So this one here, I'm trying to knock it out and get it over with. So if it's got any sort of audio problems or anything like that, then yeah, I'm probably just going to have to live with it. And if it's not perfect and everything, it's just going to have to do. The next one is similar to this, except that we are going to go in and replace another, essentially a video encoder chip that allows it to produce an image and can also affect whether or not it turns on, things like this. So we'll talk about the specifics of what that chip is, the name of the chip, what its functions are, and things like that in the next video. And we'll also show, interestingly enough as well, the chip itself is burned on one of the legs, has completely burned the pad away, and we'll have to put a small jumper wire on that as well. So it'll be an interesting repair. That will come hopefully no later than middle of next month, September, maybe the first of next month, possibly. Ideally, I would like to have a minimum of at least one every month at the first of the month. That's kind of what I was sort of shooting for, was to try and get something out on the first of every month. I was uploading a lot more frequently there for a while, but here lately it's been too busy. So we just applied a little bit of fresh thermal paste on this, and we just put that down and did not realize that we have a screw that we just covered up. So we did get the 3 screws for the fan, but there's one more little black screw that goes to hold that motherboard down, and we'll have to take these screws out and remove that heat sink to put it back in. So bear with me. There was a little bit of space there, and I was just trying to fill the space. So hopefully I'm not boring everybody with my ramblings. So this particular video actually has turned out to be fairly long. It's just shy of a full hour. So I don't know what particular times where significant things occur. So specifically the soldering of the port itself, taking it off, putting it back on. I'll probably put the times in the timestamps down in the description so that you can just sort of click to those points in the video if that's really all you're interested in. The format for these videos has been consistently, as much as possible, to keep as much of the process in the actual video as possible. Now, there are a few exceptions, but for the most part, in general, I like to do the start to finish approach, which basically demonstrates the process from the beginning all the way through to the end, so that we're not leaving out steps. Primarily, this is to sort of document the process of sort of a guide, as it were, for the entire process, so that we're not just assuming things as we go along. You can see the one screw that was down on the mat there, which just magically disappeared because I think I picked it up, is the last one that we need to put back in underneath the heatsink. So we're going to do that here. Also, I haven't really done anything particularly special when it comes to these videos. We're not using green screens. We really only have a minimum of one or two cameras that are being utilized at any given time. A third camera could be included, green screens could be included, all those kinds of things could be done if I thought that that was something that would be relevant to a video that has some significance for one reason or another. I might do something like that, but as of right now, I'm more interested in just documenting the individual repairs from a start to finish perspective, as I have time to upload. There's some other Surface Pro videos that I would like to do, basically one in particular revolving around this tablet not running off of the battery, for example, but will run off of the AC adapter. So very interesting topic that I would like to cover, and I've not yet had time to do that as well. This is where it's becoming extremely difficult for me to get all of my work done and still do videos at the same time. I suppose if I just wanted to turn the camera on and just point it at myself and my bench or something and then switch between a couple of different camera angles, then it really kind of wouldn't matter. I would just basically do, well, here's my daily workload. Here's what I'm doing on a daily basis. And hey, you know what? If you don't like looking at me or want to see me or whatever the case might be, then you're just kind of stuck with that. Yeah, some of these videos kind of have personalities that are interesting to watch. Mine is probably not one of them, so I'm not really that interested in putting myself on the camera. People can make fun of my hands and my fingernails and all that kind of stuff all they want to. I don't care. Something else interesting is that I have not been wearing really gloves for this sort of thing now for more than 20 years. I haven't really bothered, other than some occasional glove wearing. It's not been a habit of mine. But here recently, we've had to start wearing gloves just because of this sort of, well, started out kind of with the COVID thing, but basically at this point, it's starting to become more integrated in whenever we're doing anything. For example, when I'm soldering or something like that, we'll probably start seeing gloves on. But these videos are still old enough to be kind of pre-COVID at this point, so they've been ready to, well, in the making, but now for the last 5 months. So it's been pretty epic as far as business is concerned. And I'm sure that many others that may be doing this sort of thing also are overwhelmed and busy. So some of the format of these videos is not only straightforward from the start to finish point of view, but also because of that, I don't bother scripting anything out. I basically just utilize the process itself to motivate or to give me some point of reference to make some sort of voiceover. Here we have the charging indicator up here. You can see is showing that we have plugged something in, and you can see on the meter that we are pulling some amperage, and we're getting some of the numbers that we would expect to see when it's working properly. These numbers will fluctuate a little bit depending on the state that the tablet's in, whether the screen is on or off, and other things as well. So The port itself at this point is at least taking it's allowing the system to take a charge. You can see here where the where it's fluctuating here from around 10 watts or whatever. So we can kind of get an idea here that it is going to power on at least and show an image. But we do need to let it charge a little bit longer before we do any further testing. So as of right now, we can see that it is at least taking a charge using the charging cable and the port itself. But we also want to check it on the charging dock, which will also allow us to output video to an external monitor, and we'll be doing that here next. Okay, so you can't really hear the audio, but you just have to trust me. There's audio, and also we have our video obviously on the screen there, and we're just using the standard Nintendo Switch dock. So hopefully you found this video interesting and useful, and if you did, please like, share, and subscribe. It really helps us out when you do that, and we'll see you next time. Bye-bye now.